Lock in so you don't cry when you see a circle theorem question. This question was in November 2023 on a paper 3 higher. It's one of the last few questions, so examiners expect you to struggle with this, but you're not going to. The first thing you're going to do is you're going to look at your circle and you're going to label the radius. The reason you do this is because a few of the circle theorems incorporate the radius, and if you label it for yourself, you'll be able to spot those theorems quicker. The next thing you do is actually start looking for the theorems in the diagram. It doesn't matter which order you do them as long as you spot them all in the end. The first one that I spotted is the angles in the same segment theorem, and the reason why I was able to do this is because it kind of looks like a bow tie, and I call it the bow tie rule. So if you ever see a bow tie in a circle, it probably is the angles in the same segment theorem, which are going to be equal. The second one I spotted is the angles in the semicircle theorem, so we know the angle ADC is going to be 90 degrees. Now that we can't use any more circle theorem, this is when we're going to have to start problem solving. What I mean by this is see if there's anything else you can spot in the diagram. Can you see straight lines? Can you see triangles? Can we somehow figure out the angle that we want in the end from this? The first thing that I spotted is the straight line ADE, so we know that because the angles in the straight line are 180 degrees, the angle CDE is going to be 90 degrees as well. Now we can zoom in and spot the triangles that are within the diagrams. So for example, CDE is a triangle, so we can find out the angle DCE. That angle is 62 degrees, and now we can spot another triangle, which is ACD. So we know that angle there is going to be 55 degrees. Bringing it all together, BCE is a straight line, so we know that the angle BCA is going to be 63 degrees. Now, for the final step, we're bringing it all together. BDC is the angle we're looking for, and we can use that triangle to find the missing angle. The angle we're looking for is 27 degrees, and that's the answer to the question. This question is worth 4 marks, and now you know how to get 4 out of 4.